Welcome to the Demonstrating Implementation Excellence stream at SNOMED Expo 2020. My name is Liara Tatina and I'm Customer Relations Executive for Asia and Pacific at SNOMED International. I will be moderating today's session. Please use the question and answer box to type your questions presented during the session. All questions will be answered at the conclusion of the presentation. I'm now pleased to introduce Kylynn Loi from Commonwealth Scientific and Industrial Research Organisation in Australia, who will be presenting ECL in the wild, making ECL work in practice. Kylynn, please proceed.
Thanks, Liara. So today I'll be talking about the benefits and limitations of ECL, and we'll be going through the depths of SNOMED and into the health system wilderness. The objectives of this presentation is to understand the basic uses of ECL, understand the benefits and limitations of it, understand the impacts of SNOMED modelling when using ECL, and to demonstrate the use of ECL specified value sets using real patient data. I'll be referring to two case studies. The first one is chronic disease aggregation. So I spoke about this last year, so if you want full details, you can refer to last year's presentation at the SNOMED Expo. But essentially, we're looking to create standardized groups for chronic diseases using ECL queries. The second case study that I'll be referring to is some work we did with the Jamison Trauma Institute. And the Jamison Trauma Institute is a collaboration of service partners aiming to improve services to people suffering traumatic injuries. They operate in a mixed data ecosystem, and so they receive and access data from various source systems encoded in various vocabularies, such as classifications, SNOMED, free text, and many others. And so these are not necessarily equivalent in scope or specificity. This makes it difficult to do direct comparison for population-wide statistical reporting and to do analytics and research. So we worked with them to develop an overarching common layer for analysing data encoded in SNOMED CT using SNOMED logic, but still observing their own requirements and specifications. These specifications included analysis of types of injuries, anatomical sites affected, and looking into any external causes of injury. So first we'll look at the benefits and limitations of ECL. So what is expression constraint language? ECL is a mechanism for identifying concepts based on their formal definition. It matches concepts based on descendants, ancestors, relationships and groupings, number of relationships, and it does do relationship navigation. It's essentially a syntax based on post-coordination. If you do want to find out more, Linda Bird and Peter Hendler have a data analytics and expression constraint language workshop on the program, so please check that out. If you're just looking for the specification, you can find it on the SNOMED website. So ECL is a powerful tool which can be used to build subsets or value sets. Because one of the benefits of using ECL queries to build these subsets is that when you need to update, you can just run them against the new version of SNOMED. So if you design these ECL queries well, it can be less effort to maintain. These subsets or value sets can be used for data entry, so to constrain and control search, constrain data entry, to exclude content, or to reduce noise for users. But it can also be used for recall, retrieval, and reporting, so allowing the definition of criteria for recall of health records for reporting, funding, research, etc. Our focus today will be mostly on retrieval and reporting. So in terms of limitations, ECL is extremely dependent on the SNOMED CT modelling, the data requirements, so what's expected and what's specified, and then how these two interact or coincide. Also, when building large ECL queries, it can be difficult to know or control the content that is being included or excluded. ECL queries do require some maintenance if being used over a period of time, as the hierarchies change and sometimes content can change around what you're doing. And this can make it also difficult to understand changes when doing maintenance. ECL will also mostly only return active concepts, and that this can make it difficult when using historical data that contains inactive content. So as I mentioned, ECL is heavily dependent on the modelling within SNOMED. So firstly, we'll head into the depths of SNOMED. So the first case study that we did look at was the chronic disease work, and I did talk about this last year, as I mentioned, but we ideally wanted to use a hierarchy and attribute relationships to build these chronic disease value sets. So, for example, if I wanted to create a value set of respiratory diseases that were chronic or chronic respiratory diseases, I would ideally be able to just take chronic disease and chronic disease and respiratory disease and find the intersection between those two. You can see here chronic disease is defined as a disease with the clinical course of chronic, and you can see that chronic also has a number of different subtypes associated with it. But unfortunately, some diseases that are considered chronic aren't necessarily modeled that way. You can see here something like asthma. It's primitive, but it has a parent of respiratory disease and a finding site of airway structure, but it does not have an occurrence of chronic. So what you end up needing to do is relying on subject matter experts or clinical resources and other materials to essentially cherry pick or manually identify which ones you want to pick. So here I might pick asthma and all its descendants. I might also need to look at something like cystic fibrosis, and so I'm manually picking them out one by one. Another way of working around this is looking at some of the morphological abnormalities. So some of these chronic diseases here, they're not modeled with a clinical course of chronic, but they do have a morphological abnormality that contains chronic in it. So here, chronic proliferative enteritis, it doesn't have an occurrence of chronic, but it does have an associated morphology of chronic proliferative inflammation. The same here with chronic osteomyelitis, it has chronic inflammation as a associated morphology. Alternatively, you can also find morphologic abnormalities that indicate chronic but might not necessarily say it. So something like a degenerative abnormality would be considered chronic, so I can include that as well. This is just a sample fragment of an ECL query. This one here is for respiratory chronic diseases. So my second case study was the Jamison Trauma Institute or injury value sets. And the point of this was to try and build 3 sets of value sets. So the first set of value sets was to identify all the injury concepts within SNOMED and divide them up by nature of injury. So that was sort of the overarching largest set of value sets. The second set that would sit on top of it was considered a subset, which is the injuries by body structure. So we wanted to be able to cross-cut the nature of injury by body structure. So we wanted a second set that would sit across the top of those. The third set of value sets was external causes of injuries, and this one would be considered a disjoint set. So where to start? We thought we would start with something like traumatic and non-traumatic injury concepts. So you can see here the traumatic and or non-traumatic injury. It's a fully defined concept. It's a descendant of disease and has an associated morphology of damage, and that seems like a sensible place to start. So we took all the descendants or self of that concept and we ended up with 10,937 concepts. But on looking at it a bit closely, we realized that this was not necessarily comprehensive. Some of our users were a little bit confused at the number of ruptures and tears that were available within that 10,000 concepts. So we had a look and we could see all the traumatic and or non-traumatic injuries that have an associated morphology of rupture. There was only actually 95 in the list. So what we realized was that this expression did not find all disorders that are a type of rupture or tear. Clinical users, though, consider many types of ruptures or tears to be traumatic injuries, as well as some injuries that result as a complication of care, and these weren't coming up in this list. So we had a look at the diseases that had associated morphology of rupture that weren't part of our original list, and it came up with 504. So when we had a look into the SNOMED modelling, we could see here that this concept here, rupture, was not actually considered a traumatic abnormality, or even a damage concept. And rupture itself has many concepts here which aren't that don't share a parent with traumatic abnormality. So if we focus our ECL expression starting with a damage or traumatic abnormality, as we had with this traumatic and or non-traumatic injury concept, we end up missing many relevant and in-scope concepts of disruption or rupture. This applies to blisters, bites, and poisonings, as all of these are not considered to be damage, so they don't belong to the traumatic and non-traumatic injury hierarchy. But injury surveillance users regard these as in scope. So what we found was that we needed to use both the disorder and the morphologic abnormality hierarchy, and we ended up with a different inclusion expression, and this is a fragment of it here. You can see here it's descendants or self of traumatic and or non-traumatic injury, as well as any disease that has an associated morphology of disruption, any drug overdose, and any complication associated with a procedure. So it's important to remember that SNOMED's definition of injury doesn't necessarily equal your user's definition of injury, and this applies across the hierarchies. So often, simple, straightforward ECL expressions are unlikely to be comprehensive. This is just a sample of the second set of value sets, so the body site value sets. It was considered to be a subset of the first set, the nature of injury value set, but we're just specifying the attribute values for finding sites. So because our users want to distinguish particular anatomical regions, we created ECLs to match these. So example, shoulder region, upper limb structure, elbow joint structure, etc. And then the third set was the external causes. This was disjoint and it included things like events as well as situations, so things like drowning, bite, asphyxiation. So we took these three sets and we applied them to SNOMED just to identify all of these concepts within SNOMED. So on doing that, for injuries by nature of injury, so the overarching injury set, we had just over 12,000. Injuries by body structure was only 2,388. And then the external causes of injuries sat on the side, and there was only 309 of those. So once we spent the time and built these ECL, went through the depths of SNOMED, we go into the health system wilderness. So in the wild of the health ecosystem, there are many factors involved with how SNOMED is used, collected, and stored. Things such as user behavior, the user interface, and the workflow. The clinical information system itself, so how SNOMED is implemented, how it's stored, and how it's retrieved. And also things like how whether data is mandated or optional in terms of data entry. It's really easy to underestimate the impact of these factors on your data quality. And so even when you've spent the time and resource to create appropriate and considered ECL queries, the results when applied to real-world data may vary. So even when you have SNOMED encoded data, the data you receive may be from completely different hierarchies than you expected. For example, you may receive morphologic abnormalities instead of findings or disorders or procedures. If a user has an unconstrained SNOMED implementation, they might be presented to osteolysis concepts or to duodenostomy concepts. How are they to know which one's a morphological abnormality or a disorder or a procedure? So it makes it really difficult for them to pick. They may also be allowed to pick procedures as proxy instead of disorders, or substances as proxies instead of disorders. So you may find concepts that are substances as a proxy for a disease. So you often end up building queries that are somewhat agnostic to their SNOMED definitions and more tailored to what a user behavior might be. Another example of this that we saw when we were constructing the injury codes and speaking to some of the SMEs, the amputation of limb here, you can see one is a procedure and one is a disorder. But when it's presented to the users as amputation of limb and traumatic amputation of limb, the user's not really able to tell whether one is a procedure and one is actually the disorder. Another example of this is a finding and a disorder. And so for a principal diagnosis for a presentation in an emergency department, allergic reaction caused by peanut and peanut allergy are they really considered the same thing, even though one of them is a propensity to the allergy of peanuts versus actually having an allergic reaction caused? So those are some things that you need to think about. Other issues that you might have when receiving some of this data is you may end up with truncated codes. So we know that Excel truncates long codes and rounds up and down the final digit. You also may receive IDs that aren't actually concept IDs. So some clinical information systems store description IDs with or without concept IDs, and sometimes you get pre-canned extracts that return description IDs instead of concept IDs. And then sometimes you get the mix of the two, where you get description IDs with truncated SNOMED codes that have been rounded up and down. You also need to think about data extract protocols that may contain bias within them. They may have hidden includes or excludes or logic built in. And then finally, sometimes the data you receive may contain codes from different versions or multiple versions. And ECL retrieval on data that has inactivated content can be difficult and may require multiple processes. So once you've spent the time understanding SNOMED, understanding your user requirements, understanding the clinical information system, it's time to go into the data jungle. So we took those sets from the Trauma Institute and tried to apply them to some patient data. So we had a sample patient data set from a major tertiary hospital, which contained approximately 6 months of data. In that 6 months of data, there was approximately 19,000 unique SNOMED codes, which encoded for close to 500,000 patient cases. So this included primary diagnosis and comorbidities. This data contained emergency department data as well as admitted patients and was mainly the diagnoses data fields. So firstly, we applied the set of nature of injury value sets to identify all the injury concepts. So applying this identified 3,845 unique codes, and that crossed just over 75,000 patient cases. So some examples of these were sprain of shoulder, burn of wrist, open skull fracture without intracranial injury, and anticoagulant overdosage. Our next step was to use the set of injuries by body structure to cut across the nature of injury sets to allow analysis of injury cases by anatomy. Once we did that, only 899 of the 3,845 unique concepts had defining body sites, and this covered less than 20,000 of the 75,000 patient cases. So examples of these included laceration of index finger, crush fracture of thoracic vertebra, and epidermal burn of skin of finger. So when we had a look at these, we realized that many injuries did not have a defined finding site, and so this curtailed some analysis by anatomy. Most of these were either not necessarily under-modelled, but rather the injury was systemic as a whole of body, whole of health impact, so overdoses and depression and things like that. The other thing that we did notice was that the SNOMED deployment in the clinical information system allowed selection of high-level non-specific concepts, so complication of injury or post-operative hemorrhage with no indication of actual body site. So essentially the modelling available for SNOMED concepts really, it directly influences how well the ECL supports analytics. Our final step was to then apply the set of external causes of injuries to the whole patient data set, so to the 500,000 patient cases. We only returned 137 cases, and these were the ones that had event, physical object, or physical force, so the causes of injury, and it only covered 18 unique SNOMED concepts, so for example, cut in fight, accident boarding, aircraft, etc. So ECL-defined value sets for retrieval cannot compensate for data quality or comprehensiveness. It can only recall what was originally documented, and that's really important to remember. I think in this case, the reason for injury or cause of injury is an optional element within the clinical information system. So, you know, obviously many people are optionally choosing not to record it. So in conclusion, the utility and effectiveness of using ECL to build value sets or for data retrieval purposes is inherently reliant on the SNOMED concept model and the modelling of concepts available in any given SNOMED release. It's essential to understand SNOMED and the inherent limitations with the modelling available. Building ECL queries for recall is difficult and requires more than the knowledge of SNOMED. You also need to understand the exact analytic requirements, as well as what the user interface is, the user workflow, and all of the other things that are available to a user. And this makes a difference to ECL inclusion and exclusion criteria, and what expression or focus concepts are sensible and make sense. And lastly, even the most carefully constructed queries may not perform when applied if the data quality is not there to support it. Thank you. I'll hand back to you, Liara.
Thank you, Kylynn, for your presentation. Can I ask that attendees give us a moment while we switch over from our pre-recorded content so that Kylynn can address the questions you have been submitting live. Please also note that the session will be available on the event platform for the next 3 months. Thank you. Hello. Thank you for a great presentation, Kylynn. We have a few questions that we would greatly appreciate some answers to. We'll start in the order in which we received those questions. The first question is about strategies. What strategies do you use to revalidate your ECL queries between SNOMED releases, Kylynn?
So in terms of validating ECL queries, I think that's something we're still kind of working on and trying to understand completely. I guess the main thing we do is check for any inactivations of the concepts that are used within the queries themselves. We'd do a delta to look for any significant changes between different releases or different versions of the query results. We would also, because all of that would just show if there's any some changes, but it won't really account for large amounts of new content that doesn't sit under what focus concepts we've picked. So we would use release notes and knowing how often the releases are. So in Australia, AU releases monthly, so we would check that monthly, but we do know that every 6 months, for us it's September and March is when the international gets dropped in, so we're looking for larger changes there. So we're still working on that, but those are kind of the strategies we have at the moment.
Oh, thank you very much. So the next question is about the source of data. So where do you get your data? Where does it come from?
Yeah, so this data was from a major hospital in Queensland, which is the state that we're in. And it's one of the largest in Queensland. There's another question from Charles about whether the data was de-identified in the consent model. It was not de-identified, however, it did go under an ethics process through the hospital. So yeah, it fell under that.
Yeah, that's great. And do you report these unexpected exclusions? So for example, no ruptures as descendants of injury to SNOMED CT terminologists. So the suggestion here is that it may be a valuable feedback for the quality initiative project.
Yeah, for this we have not yet. We're only just wrapping it up at the moment, so we haven't had a chance to put our final report together and things like that. But it's something we would definitely do, and in other projects we would, if we note things like that would be really useful. We definitely like to submit those where we can. So the plan would be to, yes, do that eventually.
Okay, that's great. Thank you. The next question is about the focus. Would the focus be on implementation for it to use subsets relevant to the context, that is, that you never expose the user to the whole of SNOMED? When recording a procedure, you only would see relevant procedures.
Yeah, definitely you want the user to only see the things that are relevant. Unfortunately, we can't always control the implementation. So for large EMRs, they are what they are, and those decisions are often made outside of what terminologists or even clinicians may recommend. It's just what it is. And so it's really difficult to control that. I think at this particular hospital, they do a lot of education, and they do their best to try and I don't want to say restrict, but kind of constrain it down, at least so that you only have diagnosis in diagnosis fields. But there are always workarounds. A lot of the EMRs say, well, one of our selling points is that we're flexible. We allow clinicians to find whatever they want from wherever they want. So we don't necessarily have that control, and you will always find weird things in there. And you'll also find clinicians may use the EMR or the form in a different way than you expect, and it's really hard to kind of account for those sometimes.
Sure, that's understandable. Thank you very much. The next question is, how have you dealt with active concepts at point of entry that have been inactive over time at point of analysis?
In this case, we didn't account for it because I think we just had a really simple, like it was a one sort of snapshot. It wasn't that huge, and it only covered a couple of months. So can't really say for this, but in other situations, we have kind of pulled them through. So pulled them through using the association ref set as best we could, but yeah, it's something we're still working on.
Okay, thank you. And have you compared the ECL output with any ICD-10 coding that was done?
No, we haven't done that yet. We may do that in the future, but at this point, it wasn't part of this project.
Great, thank you. And how are your clinical users involved in the ECL query generation?
So the clinical users we had were, so for the trauma stuff, we had, I guess, data experts from the trauma unit, but they also had clinicians that were practicing, but were also gave time to the institute, and they gave input on the results. So they were really looking at what the results were rather than what the queries were themselves. And they were the ones who noted that there was only a small number of ruptures when they expected a lot more. And kind of, it's hard because you're trying to get them to review hundreds and hundreds of concepts rather than a query. So in this case, it was just looking at the results of the queries.
Okay, thank you for that. And with regards to the conclusions of your presentation, would you say that they apply also to generic use of SNOMED CT as well as ECL clearly?
Yeah, I think so. I think that it is the generic use. I think what ECL does, because it kind of shines light on the modelling and you're relying heavily on that to do an extraction. Yeah, it kind of is one and the same thing almost, because ECL is just using SNOMED. So I think that, yeah, I think that's a fair conclusion to draw, really.
Okay. And would you be able to elaborate on any ECL tools that were used?
Yeah, so we would generally use, we have a free tool available, which is Shrimp, and it has an ECL builder within it. So it will help you to construct an ECL query, or you can also enter like a free text kind of query. So we use that to help build the thing. So if anyone wanted to have a look, if you come to our booth, there's a link from the booth. Otherwise, you can just Google CSIRO and Shrimp, and you'll be able to find it from there.
That's great. And one more question very briefly. Is it possible today, based on an instance of healthcare event record, to evaluate its retrievability characteristics?
I'm not really sure. I'm not really sure how to answer that question. I can have a think about it and get back to you, Arturo. I need to have a think about that one.
Sure. That's fantastic. Since we're approaching to the end of the session, thank you very much, everybody, for your attention and great questions. And if you have any more questions, please feel free to reach out to Kylynn on the chat, which you will find on the Expo platform. Thank you very much and enjoy the rest of the conference.